tree diagrams. You may have come across them in sort of year 9.
Thanks, Brad.
So here's how we draw it. What the context of the question is we've got a bag of goodies. It's like a lucky dip. The guy, Mr. Muscle, he's just had his workout, and he knows in the jar there's 5 Mars bars and 3 protein bars. And he's going to take 3 out at random. He's not going to look and see what he's getting. And we're going to determine the sort of possible outcomes and the probability of those respective outcomes. So he's going to reach in, right? And on the first go, he's either going to get a Mars bar or a protein bar. They're the only 2 options, okay? Now, there are 5 Mars bars out of 8, so the probability of getting a Mars bar is 5 out of 8, and the probability of getting a protein bar is 3 out of 8, okay? And then we need to fill in the rest. So let's consider that he's pulled a Mars bar out, okay? So if he's already pulled 1 Mars bar out, that means there's 4 Mars bars remaining and 7 bars in total. So the probability of getting another Mars bar would be 4 out of 7. And the probability of getting a protein bar, well, we've pulled 1 Mars bar out, so there's still 3 protein bars out of 7 total bars in the lucky dip. So I'm just gonna keep filling it in, and I think I'll keep you at that level of explanation. So we're here. Let's say we've got 1 Mars bar in a row, and then we've got another Mars bar in a row. Now, if we've pulled 2 Mars bars out, there's 3 Mars bars remaining out of 6, and there's still 3 protein bars because we haven't got any of them. So that would be 3 out of 6. Okay. If we pulled a Mars bar out and then a protein bar out, well, we've got 6 bars remaining, and we pulled 1 protein bar, so there's 2 of them are protein bars, and 4 of them are Mars bars. All right, I might fill the rest in reasonably quickly. So if we go protein and then a Mars, that's going to be 5 out of 7, 2 out of 7.
1 out of 6.
Thank you. 6, 6, 2 out of 6, 4 out of 6. Okay, so a couple of things to notice is how at each branch, the sum of the probabilities is 1, right? 5 on 8 plus 3 on 8 is 8 on 8. 4 on 7 plus 3 on 7 is 7 on 7. So it always adds to 1. The sum of all probable events is 1. And you just got to keep track of how many Mars bars have I pulled out. That's how many remain out of how many bars are there in total. And that's how we're generating that diagram. Okay, so there's 2 parts to this problem. There's generating the diagram. If you need some help with that, let me know. I'll delve into that a little bit. But let's use the tree diagram to answer the following questions. What's the probability of getting 3 protein bars in a row? All right, so Mr. Muscle likes his protein, he wants to get his protein bar. It's going to be 3 on 8, okay, the probability of getting the first protein bar, times the probability of getting the second protein bar, 2 on 7. Times 1 on 6. I'll borrow this question. Oh, thanks. You have to leave it for me. Is that it? Or?
I think it might be the one above.
Let's check. 3 on 8 times 2 on 7 times 1 on 6. Yeah, 1 on 56 simplifies 2. Okay. So that's the probability of getting 3 protein bars in a row. All right, what about the probability of getting no protein bars? Okay, if you're going to get no protein bars, that means you have to get all Mars bars. All right, because any other path you take, whether it be Mars bar, and then a protein bar, you've got at least 1 protein bar. So this means the probability of 3 Mars bars. All right, so that's 5 on 8 times 4 on 7 times 3 on 6. So I might just work out that denominator quickly. That's 8, 7, 6 is 336, and the numerator is 20, 60. 60 out of 336. And you can simplify. Okay, so that's part 2. Part 3, at least one Mars bar. Okay, so if you get at least one Mars bar, okay, this one's a little bit tricky, all right? There's a really fast way we could do it, or there's lots of slow ways. So let's think about if you're getting at least one Mars bar, what are the possible paths you can take? So have a look here. I'm gonna sort of ruin my diagram a bit by sketching. You could get green. You could get a protein bar, and then a Mars bar, and that would satisfy that statement. You could get a protein bar, a Mars bar, and then a protein bar, and it would satisfy. You could get a protein bar, a Mars bar, and a Mars bar, and it would satisfy. In fact, you're going to find that these two and all of these operations are going to satisfy that statement. At least one Mars bar. You could have one Mars bar, you could have two, you could have three. All right. In fact, the only event where you don't get one Mars bar is this one. Okay, so the long way to work it out would be to calculate the probability of this event plus the probability of this event plus the probability of this event plus, you could add all the events up together. It's going to take a long time. The quickest way, right, is we know the sum of all probable events is 1. So if we add up all the events together, it's going to add to 1. And so that means if we want to know the probability of all of those events, we can calculate this event and do the number 1, take the probability of this event occurring, and that's going to leave us with the probability of all the remaining events. Okay, so I'm going to write it like this: probability at least 1, and I'm going to write that the best way for us to calculate that is 1. Take the probability of 3 protein bars in a row, and we've already calculated that, haven't we? Up here, 1 on 56. All right, so pretty good odds of getting at least one protein bar, 55 on 56 chance. Okay, I'll pause there. Any questions about that? Okay. All right, and then, so we've done part A, we've done part 1, part 2, part 3. We're on to part 4. So part 4 says exactly 2 Mars bars. All right, so how could this happen where you get exactly 2 Mars bars? That means 2 Mars bars and 1 protein bar. Not more than 2 Mars bars, not less, exactly 2 Mars bars. So that is this event here, isn't it? A protein bar. Let's list the ways it could happen. Actually, that might be a good way for us to do it. You could get a protein bar, a Mars bar, and then a Mars bar. You could get a Mars bar, okay, a protein bar, and then a Mars bar. All right, so it could take that path, or it could take this path: Mars bar, protein bar. All right, so we need to, the quickest way for us to do that, there's only 3 ways it can happen, is to calculate each path and then add them together. So when we think about this one, protein bar, and then a Mars bar, and then a Mars bar, that's going to be 3 on 8 times 5 on 7 times 4 on 6. Okay, protein bar, Mars bar, Mars bar. All right, the next one is Mars bar, protein bar, Mars bar. So that's going to be 5 on 8 times 3 on 7 times 4 on 6. Okay, and then the last one, 5 on 8, 4 on 7, 3 on 6. Right, what do you notice about these 3 parts? They're all the same calculation, all right? They've all got the exact same numbers, okay? If you look at the numbers at the top and the numbers at the bottom in all 3 of them, they're all the same, okay? So the product of all of them, remember we said order of multiplication doesn't matter, that's going to generate the same solution for us. And I have already calculated that because it's actually the same as this calculation as well. So that's 60 on 336. 60 on 336 and 60 on 336. And so then when we add all of these events up together, 180 on 336, and it can be simplified. Yeah. Excellent. So that's tree diagram. So we've got drawing the tree diagram and then using it to answer some of these questions. Let's give it a go.